Nhat Bridge and North Approach Bridge is located at northern area of Hanoi City, crossing Red River with overall length of 3,080 meters. Main bridge has 5 foundations constructed by the Advanced Japan Technology called as Steel Pipe Sheet Pile or SPSP. This is the first application to the bridge construction in Vietnam. SPSP material was procured from Japan as a part of STEP loan requirement. Pylons are constructed on each SPSP foundation, and the height of the pylon is 111 meters from the top of foundation slab. Approach bridge has 39 foundations with board pile, pile cap, and column. The column has 5 meters to 24 meters height. The higher column locates near the main bridge in the Red River, and the lower column locates near the approach road. Main bridge has 5 main foundations called as P12 to P16. The P12, P14, and P16 locate at the riverbank, and the foundations were constructed by on-land method. P13 and P15 locate inside the river, and these foundations were constructed by offshore method. Main bridge foundation is constructed by SPSP with 44 meters length. The permanent piles with 31.5 meters length were embedded into the ground. At the top of the permanent piles, top slab with 5.5 meters thickness reinforced concrete is constructed as a base of pylon. SPSP foundation. The oval shape SPSP foundation has around 50 meters length and 17 meters width. Inside the external piles, 4 lines of straight bulkhead piles were driven. Before start the SPSP driving work, the guide pile and guide frame are constructed to achieve the high requirement to the pile location, verticality, and the spacing between the adjacent piles. Guide frame is carefully constructed by maintaining the spacing between parallel arranged beams. Pylon structure. The pylon has a A-shaped figure with 111 meters height from the top slab of the foundation. At the middle of the column, there is a cross beam as a supporting structure of steel girder. 25,000 cubic meters, Class C40 concrete, and 1,500-ton reinforcing bar were used for 5 pylons. P12 locates at Hanoi City side river bank. Dense reinforcing bars are arranged inside the pylon concrete. P13 locates in the Red River. P14 locates in the sandbank in the Red River. P15 locates in the Red River. And P16 locates at Dong Ain side riverbank. At the top of the pylon, there is an anchor leg portion with red paint to maintain the design inclination and distance between the right and left pylon legs. Temporary strut is installed during construction and dismantled after the closure of the pylon top. Approach bridge. North Approach Bridge is connected with the main bridge at P17, and the bridge deck becomes gradually lower toward the north end abutment A2. Abutment is the northern end structure, which is the connecting point with the Nhat Package 3 road structure. Temporary facilities. To supply the huge volume of the concrete to the offshore structure, the concrete batching plant on barge was established. It can supply 60 cubic meters concrete every hour. The sandbank was the convenient yard to construct main bridge in Red River. The contractor could utilize the sandbank as a material stockyard, temporary office, rebar fabrication yard, formwork fabrication yard, and equipment maintenance yard. Main bridge. Here, the work procedure of main bridge is visibly shown. During SPSP driving, the guide frame can firmly maintain the position of the pile. The guide pile, guide frame were accurately constructed by steel members. This is the guide frame installed at P14. Between internal and external oval beams, SPSP is inserted and fixed for driving. The pile is composed of the lower pile and the upper pile. During the lower pile driving, water jet system was introduced to support vibro hammering. Lower pile is set into the guide frame, and the water jet is continuously operated during the penetration of the pile into the ground. At the initial stage of the pile driving, before the pile tip reached the bearing strata, the vibro hammer is used for the pile driving. After the full alignment of the lower pile is driven and properly connected, the upper pile is jointed to the lower pile by side welding. The qualified welders are assigned for the pipe welding. After the welding, ultrasonic test is conducted along all line of the welded circumference to confirm the soundness of the welding. Upon the jointed pipe reach the bearing strata with N value more than 50, the vibro hammer is demobilized from the top of pile, and the diesel hammer is attached. During the final driving by the diesel hammer, water jet system is not operated to avoid the loss of friction of the surrounding ground. During the final hammering, the penetration per each hammering is recorded. Final hammering is stopped immediately after the pile tip reaches the designed underground elevation. This photograph shows layout of the SPSP after the upper piles are driven. At the top of the pile, Pile opening is covered with a safety net to prevent the worker falling down. There are 4 lines of the bulkhead piles in a foundation. After completion of the closure of full SPSP, the bulkhead piles are cut at the top elevation of the permanent top slab. This cutter with long shaft is inserted into the SPSP. After the cutter is set at a certain elevation, the disc rotates and cut the pipe from inside. The bulkhead pile is extracted by the vibro hammer after cutting pipe at the design elevation. The cofferdam is composed of temporary protruded portion of SPSP, whale, and strut. This cofferdam provides the dry working space for the foundation and the lower pylons construction during the river water comes up to the high water level. Between the SPSP and the whales, the gap concrete is cast to transfer the horizontal force by high water pressure to the strut. Excavation inside cofferdam is done by using sand pump and clamshell under the water. In case the soil layer is hard to excavate, water jet system is applied to support the sand pump dredging. The excavated sand is directly discharged to the sand boats standby outside the cofferdam. Bottom slab to seal the bottom of the cofferdam is cast underwater by using tremie pipes and the concrete pump. After the bottom slab concrete achieved the target strength, the water inside cofferdam is discharged and the inside space becomes dry to start top slab work. Before the top slab reinforcing bar is arranged, the stud is installed at the inner surface of SPSP. The stud material and the stud welding team were introduced from Japan. The stud has the function to connect SPSP and the reinforcement in the top slab to ensure the bond and integrity of the SPSP foundation. The applied stud welding system can install 4 numbers of studs in a horizontal line in one operation. Top slab reinforcing bar is arranged in dry condition. After the stud is executed, the largest diameter of the top slab reinforcement is D51 and they are spliced with the mechanical couplers. Top slab concrete is cast continuously by using two concrete pumps and the supporting concrete buckets. For the top slab concrete inside the river, the transportation barge carries the concrete pump to the location, and the batching plant on the barge supplies the concrete. After finish the casting of top slab concrete, the surface of the concrete is leveled and maintains wet condition for curing. The pylon structure has a shaped figure with various inclinations in 7 faces in a section. The dimension of the section also varies from the bottom to the top of the pylon. Three-dimensional change in the pylon section shall be precisely controlled in reinforcing bar arrangement, formwork installation, and the concreting work. To enable the reinforcing bars and the formwork setting in the required accuracy in positioning, the face-by-face steel frame cages are fabricated and installed at each pylon face. The first face reinforcing bars are installed along the preset steel frame cage. The vertical main rebar has a large section which is D51 maximum. The interval of densely arranged rebar is strictly controlled to enable the spacing of for concreting. The prefabricated rebar cage system is one of the most cool technology in the pylon construction. Along the steel frame cage, reinforcing bars are installed on land prefabrication yard. The reinforcing bar cage is lifted up together with the frame cage to the higher position in the pylon to achieve the rapid construction progress. It also provides the accurate fabrication of the rebar spacing and the positioning. Each joint between the rebar cage is connected with the mechanical couplers. To cast the pylon concrete at the high position, the self-climbing formwork and stacking system was designed and applied for pylons with more than 100 meters height. It provides safe space for workforce and better productivity with less manpower. The construction stages for the self-climbing of the formwork is fully controlled by the experienced mechanic and survey teams during full operation. The rebar cages are divided into sections so the tower crane can lift up the piece of the cages and formwork without mobilizing the additional large capacity cranes. After the rebar cage is properly installed, the formwork panels are installed at the position. Grade C40 concrete is cast for pylons. At the lower faces at the pylon, the concrete pump and bucket are applied for the concreting work. At the higher faces at the pylon, the custom-made concrete bucket lifted by the tower crane are applied for the concreting work. After the lower part of the pylon is constructed, the cross beam is executed to connect the both pylon column. The support system for the cross beam is introduced from Japan as brand new material to ensure the capacity and efficiency of the work. The cross beam horizontal support is designed by using brackets and steel H-beams. The reinforcing bars, the PC strand, and the anchorages are arranged at the cross beam. The concrete for the cross beam is cast by using concrete pump. After the concrete achieves the required compression strength, the PC strands are tensioned and the pre-stressing is introduced at the cross beam. After the cross beam construction, the pylon bottom is backfilled, compacted, and leveled to provide the final ground elevation. For the higher pylon face construction, a vertical passenger hoist is installed at the lower pylon and an inclined passenger hoist installed along the upper pylon legs. During the upper pylon construction, temporary struts are provided to keep the design position and inclination of the both pylon legs. Struts also provide the access way between the pylon legs. Here, the detailed work procedure of approach bridge is presented. The foundation pile of the approach bridge structure is the cast in situ board pile. By using the earth auger with drilling bucket, the pile location is excavated. Verticality and the hole diameter is checked by ultrasonic monitoring machine from the bottom to the top of board hole. Prefabricated rebar cage is installed by the crane into the board hole vertically. Rebar cages are spliced and clipped. Concrete is cast by using tremie pipe into the board hole, which is filled by bentonite liquid to stabilize the board hole. The concrete is cast continuously from the bottom to the top of the pile cut-off elevation. Before starting the pile head treatment and the structure excavation, the sheet pile is driven to make cofferdam surrounding the excavation area. Each sheet pile is properly jointed with the adjacent sheet pile at its side sections. After sheet pile cofferdam is stabilized with wales and struts, the structure excavation is done up to the bottom elevation of the graveling and the lean concrete for the pile cap. Then pile head treatment follows. After the lean concrete is cast, at the bottom of the excavated area, reinforcing bars are installed onto the lean concrete. The spacing of the rebar, especially around the pile cut-off position, is carefully adjusted and maintained. The order-made steel formwork system is installed for pile cap concrete. Concrete is continuously cast for pile cap by concrete pump. Reinforcing bars are installed from the scaffolding staging surrounding the column. Prefabricated rigid steel column formwork is order-made and installed for the concreting work. Such formwork system is recycled between the columns by systematically adjusting the height of column wall. Two kind of pierhead beam construction method was applied for the approach bridges. One is the self-climbing staging system. It is installed at the bottom of the column first and climb up by itself along the rail vertically installed at the column. This system provides the staging and bottom formwork of the top beam of the substructure. This system was applied for the columns which have relatively taller height among the piers. Above the staging, reinforcing bars are installed. The second pierhead beam construction method is the conventional all-stagging method by using brand new Japanese scaffolding material. It covers all surrounding space of the piers and provides support and accessway at the same time. This system was applied for the column, which has relatively lower height. Steel formwork is installed after the rebar work completes. Concrete is continuously cast by using concrete pump. Temporary work. For the project concrete work, the substructure group established the batching plant on barge together with two numbers of batching plant on land. Total production capacity was 210 cubic meters per hour. 10 numbers of truck mixers support the concrete transport, which total volume was 150,000 cubic meters. Tower cranes are established at each pylon position. They were procured and imported from Spain. These cranes have flat gib with 550-ton-meter lifting capacity, 130 meters height. The pylon steel formwork was designed and imported from Malaysia. It can be applied for all phases of the pylon's construction by adjusting the dimension, inclination, and combination. After finishing each phase concreting, the formwork pieces are cleaned and kept maintenance at the formwork fabrication yard. Temporary access road is constructed inside right-of-way. The road maintenance team, which excavator and dump truck, is always taking care for the road surface condition and repairing during the project period. A steel pipe sheet pile was procured from Japan and it was stuck in the project yard for the SPSP foundation. The sandbank was the convenient construction yard for the project. Various kinds of material, equipment was stocked, utilized, and maintained during the temporary yards. The bridge substructure and the main bridge pylon work started from October 2009. During more than 3 years substructure construction period, the Red River water recorded the historical lowest elevation and highest elevation. The height difference reached 10 meters. The contractor's technology and energy to wish to complete the project successfully achieved one of the largest advanced bridge substructure in Vietnam.